To find the moment of inertia of a thin square plate which has approximately zero thickness, on which mass is distributed over its area, we will consider that thin plate is composed of infinitesimal number of the thin rods. We will find the moment of inertia of the particular rod, and then we'll integrate to find the total moment of inertia of the square plate. So for this, first we will draw the figure. Suppose this is the square plate whose sides is A, and the axis through the centers is one axis x-axis horizontally and another vertical axis is the y-axis. So we mark it. This is the A side of the square. Width is also A. Horizontal axis is x-axis and vertical axis is y-axis. Axis through the center and perpendicular to the plane of the square, this axis is z-axis. To find the moment of inertia, we will take an elementary rod of thickness 0 or say very small. This is the elementary rod. This is at a distance say x and its thickness is dx. We will use the formula for the moment of inertia for the rod about the axis passing through the center and perpendicular to the rod, which is I equal to 1 by 12 ml square. M is the mass of the rod and L is the length of the rod. And this formula is applied for this elementary rod. So we will have dIx, where Ix is the axis through the center and perpendicular to the rod, and moment of inertia will be equal to 1 by 12, and elementary mass of this rod is dm say, and length of the rod is a, so it is a square. So to find the total moment of inertia about the x-axis, Ix will be equal to integral dIx. So it will be equal to integral 1 by 12 into dm into a square. 1 by 12 and a square are constant, so remaining is dm. Because we are integrating over the whole square plate, so on adding the elementary masses of the elementary rods, we will have the total mass of the square plate. So it is 1 by 12 into a square into capital M. Therefore, moment of inertia of the square plate about the axis which is through the center and in plane of the square plate, this Ix will be 1 by 12 m into a square. Similarly, by symmetry, we can write that Iy will also equal to 1 by 12 m a square. And now we can find the moment of inertia of the square plate about the axis through center and perpendicular to the plane, and this axis is a z-axis, which we have shown in the figure. It will be equal to Ix plus Iy from the perpendicular axis theorem, and substituting the value we will have 1 by 12 ma square plus 1 by 12 ma square, and this will give Iz is equal to 1 by 6 ma square. Let's take a rectangular thin plate.